Welcome to Orchestrate All the Things. I'm George Anadiotis and we'll be connecting the dots together. Stories about technology, data, AI, and media and how they flow into each other, shaping our lives. Graph database growth is going strong through the Trough of Disillusionment, and graph analytics go big in real time. Those were two of the headlines of the Spring 2023 update of the Year of the Graph newsletter. In combination, they seem like an appropriate summary of the reasoning behind a new entry in the graph database market, Aerospike Graph, which Aerospike officially unveiled in June 2023. We caught up with the company's Chief Product Officer, Lenley Hensarling, to discuss this long journey that started about 3 years ago, as well as Aerospike's differentiation in a very densely populated market. I hope you will enjoy this. If you like my work on Orchestrate All the Things, you can subscribe to my podcast, available on all major platforms, my self-published newsletter, also syndicated on Substack, HackerNoon, Medium, and DZone, or follow Orchestrate All the Things on your social media of choice.
Yeah, well, thanks. Glad to be here, George. And thank you for your efforts on the white paper. It turned out really well. Yeah, I've been at Aerospike now for, almost 5 years. And I came to it with a background in enterprise software, sort of across both infrastructure, databases, networking, and also large enterprise applications. So enterprise resource planning, manufacturing, logistics, things like that. So I was a big user of databases. And so I've been on both sides of it and different types of databases too. And did work on directory services, which were some of the first users of in-memory databases back in the day. Here at Aerospike, I came in as a consultant on strategy and then became chief strategy officer and then put together the product management group here. And now we have a strong product management group. I know you've worked with Ishan Biswas, who's the product manager for Graph, which we're going to talk about today. And my whole focus has been trying to figure out how we apply more data to decisioning, throughout my career. How do we do that in a way that's cost effective, right? We know that there's a net yield because there's a cost to run the computers, there's a cost to manage things and to program applications on top of databases. So all those things come into factor, but that's been something I've been focused on and also focused on what I jokingly call catching up to the present. With databases and software in general, we haven't been able to reflect what's going on in the moment. We started out with batch solutions that we could tell you what happened last month, and then it's got progressively better. And now we're still trying to catch up to the exact moment, and the world just moves faster. So, we say milliseconds matter.
Okay, well, great. Thanks for the intro. And I guess the next reasonable question to ask, at least for someone who's not necessarily familiar with Aerospike, is, well, what's the key premises? What are the key premises behind Aerospike? And therefore, I guess by extension, what was it that attracted you to join the team?
Yeah, well, two guys started Aerospike, one of whom I knew from my past in networking, Brian Volkowski, and one of whom I've worked with a lot in the last, almost 5 years, Srinivasan. And Brian came from a networking background and a storage background, working with SSDs and all the way back to, file servers and such. And Srini came to it from a strong theoretical database background. He's one of those PhDs from University of Wisconsin, which, historically has been kind of one of the database research institutions. The whole hypothesis of Aerospike was that companies needed to apply more data in a short time window with a predictable service level agreement, or SLA, and to do that in a cost-effective manner, as I was saying earlier. And this notion of being able to do that and do that cross-cloud and on-premise was something that was key to the founding of the company. The other thing I'd say about Aerospike is that we are a true infrastructure system software company. And we have a different type of engineer than a lot of companies. We pay attention to, how we handle concurrency. We exploit the hardware that's available now. And, I'll say that people say, does that matter given that everything's in the cloud? Well, there is no cloud. It's just somebody else's computer. And it's a networking infrastructure, and you have to optimize for that. And so the engineers we have think deeply about these things. We have massive throughput in the product, and that's a result of this concurrency and multi-threading and coding specifically so it scales like that. And I think that attention to detail is what really differentiates Aerospike from some of the other NoSQL and databases in general, really.
Mm-hmm. Okay, so you just said the magic word, so NoSQL. I was going to say that, well, everything you've just said sort of makes sense, but you didn't actually mention what I would probably start with. I mean, the fact that Aerospike is, well, a key, at least initially and primarily, a key value store. I know that over time you have expanded that to also touch upon different data models as well. And actually, that's the occasion for having this conversation today. I mean, the fact that, well, the latest addition, let's say, to Aerospike's arsenal is the expansion to Graph. But before we get there, I think it's worthwhile just covering a little bit the key, the initial data model, so key value store, the key value aspect. So this is the where Aerospike started from, and then also the additional data models that you have expanded to over the years, and a little bit of the thinking behind that.
Yeah, sure, George. It's great that you brought that up. Really, what we focused on initially was, as you said, a key value store, and we had some differentiation there. The primary index is in a model we call hybrid memory. The primary index is held in memory. The data is stored on SSDs, but we treat the SSDs as a memory space, if you will. We don't write to it as a file system. We don't write to it as block storage, but we treat it much like memory. And this has made it possible for us to get access to a given piece of data in sub-millisecond time. So going through the primary index, we've expanded that to support secondary indexes that are held in memory, but also can be held on SSDs as well. And that's allowed us to expand the things we can do with it. The other thing that's worth mentioning is that it is a distributed database. And so that always raises the question of how do you partition the data? How much work is it to figure out the partitioning model? How do you manage that? And we've done this in a way that we can partition the data for the customer. We can ensure that there are no hotspots, and then as data access patterns change, we can move the data around and change the partitions, and this goes on in the background as required. So there's not much involvement required to exploit a very distributed architecture so that we can scale up to data sets in the size of multi-petabytes. But with those large data sets, we can still gain access to a given piece of data off the primary key in less than a millisecond. So we're talking microseconds there. We can do queries on the secondary indexes that are single-digit millisecond. And that's because of the way we handle the balance between indexing in memory and data on the SSD, and being able to handle the indexes on SSD as well for very, very large data sets, but still approaching it as if it was a memory space, if you will.
Mm-hmm. Okay, I see. And so I know, if I recall correctly, then starting off with the initial key value model, I think you have expanded in recent years to also touch upon documents. So I think Aerospike also supports JSON now. And I think you also have like a SQL interface as well.
Yeah, so one of the things that we looked at was we essentially have figured out storage and access to data on a key model, both primary index and secondary index. And we started out with what I will call a simple value type, one type of data, whether that's an integer or whatever. But we moved to something we call complex data types, or CDTs. And so that's essentially an object. So with a map list structure or JSON structure, depending on how you want to cast it, if you will. And that allowed us to support documents, or to support object persistence, if you will. Because documents, as we're talking about them here, are really just a way to persist objects in an object model, programming model. So we got to that point. Then we started looking at what some of our customers were doing with the product. And that was around graph solutions. So a number of our customers are in ad tech and in fraud. And those are two places where identity management or identity resolution has become ever more complex as we try and throw more data at the problem. It's not just your username and password anymore. It's your username, your password, your history. Trying to triangulate, the devices you use, where you are, who you're with, even, and be able to handle things like that. And as we saw them doing that more and more, and doing it on top of Aerospike, as a key value store, we looked at an evolving pattern where some of our customers were using an open source graph technology that I know you're very familiar with, George, Tinkerpop. It's an Apache project. And they had been doing this, themselves, basically building a solution on that, and then putting it on top of Aerospike as the storage model. And we saw that scaled far beyond what other solutions in the graph space did. We talked about being able to scale to petabytes of information and still have the access times remain very low. Okay, we talked about being able to balance the data between partitions, right? And so they were exploiting that and doing that with graph solutions based on Tinkerpop. What we did was then started talking about, could we do that? Talking to some of these customers, right? Talking to other customers who are looking at the landscape of other graph solutions. Neo4j is a great product. Tiger Graph's a good product, and really tried to tackle the scale issue. And we thought that there was some white space at the level we play at, which is very large data sets where there's a demand for near real-time performance. And so then we started investigating Tinkerpop ourselves, started experimenting with a layer that would tie Tinkerpop back into Aerospike as the storage mechanism, defining the data models for it. And the first thing that we've done is come out with an identity management solution based on Tinkerpop and the Gremlin query language, if you will, right? It's more than a query language. I would say it's a graph language, more than just a query language. And we put together a solution that, together with Aerospike, we think meets a need that exists for this, high scale, high throughput, and low latency capability. And we've been in several proof of concepts now with customers. And we started that before we released the product, actually, working directly with some of these customers, and have sort of proven out the solution. And we'll move it forward, going in the next year and support an OLAP, an analytical graph solution as well as the identity graph solution that we have in the marketplace today. And we'll just expand from there, building more solutions and providing it. I should mention too that we use a tool called G.V. I think you're pretty aware of it. It's a nice tool. It's an IDE essentially for Gremlin, and it allows you to visualize your graph. It helps you to step through queries and things like that. All those things that developers really need to do, and that's kind of the path that we've gone down to. And in some sense, what we're doing is putting different personalities, if you will, on top of a very robust storage and access mechanism.
Okay, so it sounds like quite a journey. So I'm wondering, how long did it all take you? I mean, from the moment you became aware of clients actually using building their own sort of ad hoc solutions for Graph on top of Aerospike, to the moment you decided that this is something that you would like to pursue as an official, let's say, implementation, up to the moment where you were actually able to release it?
So there are two answers. One's about 3 years, right? From the first time I saw this. We have a very large customer who's in the payment systems business, and they were using a graph solution like we're talking about here, built on Tinkerpop, at scale, with billions of vertices and thousands of edges, connecting them all. And the first time I saw that, I kind of went, wow, why don't we do something in that space? It was just a thought. And I started educating myself more and more on Graph, right? I hired a product manager. I think I called him out earlier, Ishan Biswas. And Ishan started really digging into it, working with these customers directly. That was probably another 6 months. And then it took us about another year to hire the team and implement the solution. And essentially it's, taking the Tinkerpop graph engine, if you will, and making Aerospike the storage mechanism for that, and really creating a graph database. And as I said, that took about a year. It took probably 6 months to get something up and running because we were leveraging Tinkerpop. It's an Apache 2 solution. But then, as with everything we do, we wanted to make sure that it did scale, that it had high throughput and such. And so we worked, and refined it, and we'll continue to do that. I think software is always a journey. But in the last year, we've been able to do this and released, I guess it was, probably 4 or 5 months ago, our first solution. And as I said, we'll follow that up with an OLAP solution so that people can do more analytic exploration with the graph, and do that. And, we see that tying back into, there's this interplay in the ad tech business, and that's a large vertical for us. It's not the largest anymore. I think financial services is, but they share characteristics, fraud, identity management, and identity management or graph in support of those. But really trying to get to solutions that are more out of the box for customers. Graph's not simple, as you know. It's a different mindset, and we're trying to package data models for specific solutions with our graph capability as well.
Okay, yeah, that's certainly interesting, and I think if you get to that point, it's going to be very helpful for people to be able to at least have a starting point out of the box, so they don't have to model everything from scratch. Modeling in Graph is, well, a fine art, let's say, and it takes a while to master it. So if you can give people a head start, I'm sure they will. That will be appreciated. There's also something else I think worth noting. You did mention the fact that, well, Aerospike Graph is largely based on Tinkerpop, which is an open source framework for for managing graph. It offers its own query language, it's called Gremlin, but as you also briefly mentioned earlier, it's actually more than that. So part of the appeal, let's say, that Tinkerpop has is the fact that it can basically plug into any kind of backend. So it provides a service provider interface through which theoretically any provider can implement that interface, and so make their database or whatever other data management system work as a backend for Tinkerpop. And I'm sure that this is the process that you also went through, and in order to achieve that and also be able to have that sort of performance that you were after, I'm sure that it took lots of knowledge that you definitely have in-house about the specifics, the specific APIs and implementation and everything that has to do with Aerospike, but you also needed to get a good understanding of the Tinkerpop fundamentals. And so I know that in order to do that, you actually went and hired some help, and probably the best one you could possibly get as far as Tinkerpop goes. So I wonder if you'd like to share a few words on the collaboration with none other than Tinkerpop's founder, so Marco Rodriguez. I know that you worked rather closely during that implementation stage.
Yeah, we actually hired Marco as a consultant, and then we also hired a number of other people who've been very active in the Tinkerpop Graph open source community in working that to build out. And as you said, there's a service provider interface, and then the work we did was how best to implement that back to Aerospike, specifically in service to identity graph models. And the work we'll do on OLAP, right, or the analytical component, is to make sure that we have optimized use of Aerospike in the way it handles storage for that. And we had the project code name was Firefly to build that interface. It's non-trivial is what I'll say, right? We went through some what I would call naive implementations that were not as scalable as we would like, that had certain hotspots, if you will, where you have nodes that get hammered too much in it, and we had to figure out how best to handle that. Over time, over this last year, we've really come up with a very sophisticated interface layer to our storage. The other thing I should mention is that the graph engine itself and this layer that talks to Aerospike have been built in a way that they scale out horizontally in a shared nothing sort of model. So the graph engine that's essentially just requires compute and networking attachment to Aerospike can be sized on instance types in the cloud or hardware that you might purchase that are specific to that part of the application, and they scale independently to the data set. So you can have your Aerospike cluster running, and it's distributed, but the implementation of Tinkerpop and the connectivity to the database scale independently of that. So if you have high throughput, and since it's shared nothing, you can spin up nodes and spin down nodes as you have need to in terms of how much throughput, how many connections you're going to have. And that ability to be able to elastically scale that while you have the persistence handled elsewhere is a big cost savings to people where they have variable workloads. So there's a great deal of elasticity built into the solution as well.
Mm-hmm. Okay, I see. So how would people actually get started with Aerospike Graph? And I think there's probably two different categories to address here. So existing Aerospike users who presumably already know the basics of how to use vanilla Aerospike, let's say. So how would they get started using Graph, and how would someone who's not an existing Aerospike user get started with the new product?
So, we packaged it in a way that you can deploy Aerospike and then deploy the Graph engine independently to some extent. You can actually get a free trial of both components, both the storage engine in Aerospike and the Aerospike Graph service as a free trial and download that. There are Docker images and for both, and that can be deployed relatively easily. When you go into production, it can become a little more complex and require a little bit more sophistication. But you can download that free trial. The other thing that we're going to have, and I think this will probably be Q1, maybe into Q2 of next year, we'll have a DBaaS solution. We've recently announced our trial, free trials on a database as a service of Aerospike, just the Aerospike engine. And we'll have a similar thing up and running, like I said, in the first half of next year. And when we have that, it'll become very easy because you'll just, say I want an endpoint and be able to play with that, and we'll handle the scaling of the Graph engine and of the database behind it for you. And so that'll greatly simplify things. But right now, the free trial can be downloaded and installed on your laptop. It can be, installed on your favorite cloud vendor, etc.
I see. Okay. And so that covers the actual installation part, I guess. So what about, I don't know, support and documentation and education material? So where should people look for that? I know you already mentioned that there is a graphical interface specifically for the graph part that people can use. So it's called G.V. And as far as I know, you have a partnership with the vendor behind G.V.
Yeah, we're actually including links to download the community version of G.V with our free trial. And when you download it for pretty nominal fee, you can buy the enterprise versions of G.V through gv.com, right? They're a great partner, and it's work that was done by somebody who's used Tinkerpop a lot themselves and saw the need for this tool and built it out. But that's easily done. I think that the documentation on the solution is all available on our website. You can go to our dev hub, devhub.aerospike.com, and there are forums where people can get help on doing this. You can get access to the documentation. You don't have to buy anything to go read the documentation and understand that. You can get the free trial and get help through the forums on our developer hub.
Okay, I see. And you also mentioned something else previously about the primary use cases that you are targeting with this release, at least initially. So you mentioned ad tech and finance, and the thing that these two domains have in common, so building identity graphs, and those are typically used for fraud detection purposes. And I think it would help to add a little bit of background to that. So the reason that Graph is a good match for that is that because, well, lots of graph algorithms can be beneficial for this particular use case. So you have algorithms such as PageRank or breadth first and so on that are often utilized in that context, because in order, you also mentioned the fact that, well, it's not just about, well, who you are, it's also people these days in the context of anti-fraud are also checking things like, well, what is your network like, or where are you based, or how often do you try to execute certain actions, and so on. So graph algorithms can actually help with that type of anti-fraud action. So I'm wondering, in order for people to actually utilize those algorithms that are, to a large extent at least, supported inherently, let's say, by Tinkerpop. So where should they be looking? Do you have like maybe some kind of pointers for them? Like if I want to implement an anti-fraud solution, for example, do you have existing use cases that you can direct them to?
We have some use cases written up. One thing I would say is that in general, and George, you and I have talked about this before, the graph, the graph solution world is one that's still evolving, and new ideas are popping up all the time. But what's driving it is really the need to have alternate ways to, just cookies, is one of the things that's happening. People became concerned that Google and Apple might take cookies away, from Chrome and Safari. And then how would they be able to get the same level of validation? The other thing that I think is, in some ways, a bigger driver is that in order to validate things, there are bad guys in the world, bad actors, and they're always learning how to spoof or fake more and more of what we all use to try and validate identities and make sure it's you that's moving the money and not somebody else. But applying more data and more information about you and who you might be related to. And if I'll give you an example, if an IP address is outside of the realm or connected with bad actors or something like that, or it's from a part of the world that there's just no way you've visited, and being able to see things like that tied with your device that might not be your device. Somebody may have faked that. And then they're checking all this level of complexity of interconnections to validate identity now. And as they gain access to more and more data sources and want to figure out how best to resolve that and to make use of that information, that's kind of what we're seeing. And there's a lot of literature out there, just all over the place, I would say, in the Tinkerpop community, on their chat boards. There are chat boards out there just on Graph. And as I said, we have our developer hub, where we take questions and can answer questions as well. The developers that work on our solution, monitor periodically those things. The product manager monitors them, and we respond with information on it all there as well.
Okay. All right. So, well, then I guess now it's time for me to wear my analyst hat. And as an analyst, graph and graph database is a space I've been covering for a while. So one of the characteristics, let's say, of this space is that, well, there's lots of divergence. There are many solutions out there. Well, some people say there's even too many of them. So last time I checked on DB Engines, there were about 60 different graph databases in total, which is a lot, obviously. So whenever there's a newcomer, let's say, in this market, the first question that naturally comes to mind is like, well, okay, first of all, welcome, and nice to meet you. But then, all right, so after the initial welcome, what makes you special? So what is it about vendor XYZ? In this case, what is it about Aerospike that makes it stand out from the already numerous solutions out there?
So George, I think that's key. Typically markets will have many, many participants. We've got, I don't know, there's 60, 70 graph solutions out there, as you mentioned. We're in a space, the database space, that's evolving pretty fast right now. And there are literally hundreds and hundreds, 400, 500 different databases that are all competing for some space. One of the things that we've done is differentiate along a couple specific vectors, right? I mentioned, the notion of real time, and it's not just being able to respond to queries with low latency. It's the ability to do that consistently, regardless of what the load is. Okay, meaning if you have a few hundred people coming to your database and trying to get a graph answer, that's pretty doable for most, solutions. If you have hundreds of thousands per second, if you have millions of queries per second, then it's a different question. And the ability to keep up with that is something that in our database we focus on, and something that we've focused on in how we built out our implementation of Tinkerpop. I mentioned that having it be able to scale horizontally, very fluidly, and then exploit the ability of Aerospike to handle the multiple connections back from our interface to Tinkerpop, the layer we built there, and have that scale out as well. And to do that in a consistent manner, with low latency, even when you have, high workloads, and even when the data set has grown to significant size. We have a t-shirt that we hand out at meetups for Aerospike that says, write once, scale forever. And one of the things we really believe is that, the application of more data, we've come out with a term we use a lot now called aspirational scale. Even if your solution in the beginning has, thousands of users, not hundreds of thousands, not millions of users, right? You need to plan for that number of users, that much throughput. You also need to plan for data sets growing. One of the things we've seen over the last 5 years for sure, this has been going on with Aerospike for, I don't know, let's say we're going into our 15th year now of being a company, that people are adding more and more data sources all the time. An anecdote I'll tell you is that we have a customer in the ad tech space, and I naively ask, how many data sources do you add a year? And he said, well, we don't look at it that way. We add tens of data sources a month. And, all of this to refine exactly who's there, what kind of knowledge you can have about the person, presenting themselves, if you will, and to tailor and really understand where and what types of ads might go to that person. And by the same token, when it's financial services, what does it really mean? Is that the person? Is this activity normal for them? Does that activity match up with the size of the transaction? Where they are and things like, if you or I, show up in a part of the world we never go to and ask for sums of money that we don't normally ask for, or to sell stocks and transfer the funds, we'll probably be denied. At the same token, when we go down and exercise some things out of our portfolios because it's time to buy a house or time to buy a new car and we want a down payment, we don't want a lot of friction in that, right? And the ability to apply all that data to mitigate risk, if you will, but do it in a way that's relatively frictionless, is what's driving all this. The other thing I'll say is that there's a new thing happening. This is behind a lot of the demand we're seeing for graph solution, is that In streaming media, TV is no longer TV, it's an internet app, if you will, right? And so people are wanting to understand who's in the room watching TV. Might be the neighbors. They might be the more interesting person to advertise to, right? And so they know they're trying to buy a car, so they'll get car commercials, even though it's your house, right? Because they know, what devices are in the room and where those devices have been and things like that. And so there's so many different, vectors of information that are coming in right now, and that people want to apply. One of the few technologies that can do that well is graph technology because it's about associations, if you will.
Mhm. Okay, so I guess the takeaway would be that it sounds like you consider performance and scalability to be Aerospike Graph's differentiating factors, right?
Yeah, absolutely. And I just always want to reiterate that performance is not just low latency, it's also the throughput. It's the number of connections you can support, the number of, people that can come. A person on our board of directors has a great statement that he makes. He said, like, he mentioned the non-linearity of the internet. And what that means is, when you open your service, whether it's, selling shoes or delivering laundry or delivering food, you don't know how many people are going to show up. It's not like a store that's physical, and nobody wants to wait in line on the internet, right? People expect the performance of your applications to be consistent, and they don't care that there are 100,000 people there when they showed up, or a million. And being able to handle that throughput as well is a key factor, as well as the size of data and the low latency.
Mhm. Okay, so then I guess the next question that as an analyst, I ask people when they tell me that, well, we're focused on performance and so on. It's like, fine, okay. So I guess then you probably have you probably have done some benchmarking to be able to support that statement. And so I'm guessing that also applies to your case. So have you done benchmarking, and are people able to check on those benchmark results? And I should also add a disclaimer before actually hearing you out that, well, even if you have, I always encourage people to check the benchmarks and then actually also do their own local benchmarking, let's say, using data that's representative of their own use cases and a setting that's also representative of what they are able to support. Because, well, the thing about benchmarks is that, well, they're only indicative. What really counts is the actual performance in your actual setting.
Yeah, I would agree with that strongly, George. I think that what's given me the most comfort that we do scale and we perform is not just the benchmarking work we did. We've done some what I would call nominal benchmarking up to several terabytes of data, and tens of thousands or hundreds of thousands of transactions a second. But we've done some proof of concept work, POCs, with actual customers using their actual data that they wanted to. And it bore out what we've seen in our benchmarking, which is really that for, let's say, 2 to 5 hop queries on a graph, it's between 3 and 7 milliseconds to get your answer, and that is invariant over large workloads. And so we've done that both with some anonymized data that we got from customers, but like as I said, what's given me the most comfort is that they have taken their data. We've worked with them to implement the specific, identity graph models that they were going to use, and with their own data, which gets loaded with in parallel with Spark, right? So that we can, hydrate the graph, if you will. Um, and that those results have borne out as we have. We're currently, working on models that will be able to scale out, and then we'll in the cloud test this out with more hardware applied. But some of these customers, both on-prem and in the cloud, have put together very large data sets and run POCs for pretty high levels of concurrency and throughput.
Okay, I see. So to come back to the previous topic of, well, this market being very densely populated, let's say, by a large number of vendors sort of vying for market share. One of the things that caught my attention recently was that one of those vendors that relatively recently entered the market, so about 5 years ago, namely Redis. Redis is an interesting case because they seem to have walked a similar path that you are walking down now, having a sort of similar motivation, let's say. So initially, Redis was obviously, as people know, not a graph database per se, but because of the fact that they saw that, well, some of their clients are using graph, they decided to add a graph extension to their offering and make it an official part of their product, let's say. Now, 5 years later, and about 4 or 5 months ago, unfortunately, Redis made an announcement that they're winding down that offering of theirs, and they cited a number of reasons for doing that. Basically, they said that, well, even though they were also very confident and very happy with their implementation and its performance and scalability and so on. What they found out, actually being in that market for as long as they have, was that it was a hard sell, basically, because of the fact that compared to other data models and implementations based on those models, Graph was harder for people to wrap their heads around. Therefore, their projects took longer. They needed more help to get started and to walk them through. And in the end, it ended up not being viable for them. Basically, that was more or less the reasoning that they gave for exiting, for sunsetting their product the way that they did. So because of the fact that I do see some parallels between what drove them to enter the market, that market, and what has driven you to enter that market, do you think that there's anything you can learn by their experience and anything you can do differently so that you don't end up the way they did?
Yeah, I think that we noted that when they pulled out, and when I was doing my research for this, they hadn't gotten that much traction, and that's what they're saying, right? They just didn't get traction. I think that some of this is a question of sort of being fairly laser targeted, on what we're going after, and our product's very differentiated, focused on scale and performance, and the scale part. So Redis, sort of grew out of being cache, if you will, sitting in front of other databases, and that's still their primary use, and it's a great solution for that, right? And used very widely. We are more of a database and are used to selling more at the enterprise level and into more complex solution spaces, if you will, right? For us, we've recently entered the market with a database as a service. It'll go commercial, and you'll be able to just purchase with your credit card or your account, on the cloud vendor, and do things. But really, when you're designing enterprise scale applications, it's not a simple thing. And getting the data models correct and such is not that simple. So we have the infrastructure in terms of both pre-sales and post-sales staff that help people develop complex solutions and solve complex problems. And so I read their announcement of, sort of withdrawal from the market. And they said they like to focus on simple things, do simple things well for, developers. And there's a space for that. The white space we saw in the marketplace was not the easy space, is what I would say. It was the space where people like this payment system that I mentioned, and some of our ad tech customers that are pursuing uh, ad bidding for streaming video, right? That they're trying to solve complex solutions or problem sets with complex, varied amounts of data. And they don't expect it to be easy, and we don't expect it to be that easy to sell into either. We're always wanting to reduce the friction, hence the free trial, hence the database as a service. But we're focused at this space, and they're focused at easy. And I think that, that's why there's room for both Redis and Aerospike. We have a lot of customers that have Aerospike, running, supporting, petabyte data sets and things like that. And then they may still use Redis, not on top of us because we don't require cache, we're so fast. But they may have relational databases or mainframes or whatever that they're just a cache in front of. And we see that quite often.
Mhm. Okay, so I guess then the takeaway is that, well, the market segment that you are targeting is different, and in a way, they accept, they embrace complexity, and therefore you're not afraid that that complexity, which is to some extent inherent, let's say, in graph, may sort of deter them.
Yeah, I think there is a space in the market, and it just so happens to some extent that it's our customer, our historical vertical footprint has been strong in financial services around fraud and strong in ad tech. And that means both streaming, ad as well. And that those spaces have a demand, that they have a need, there's an unmet need to solve this problem that graph is a good solution for.
Mhm.
It's not
Okay.
every company, but it does fit well with our focus.
Mhm. Okay, so speaking of complexity, actually, there's also something worth adding in that respect. So we did mention previously the fact that, well, Aerospike Graph is built leveraging Apache Tinkerpop. So Apache Tinkerpop, for all its strengths, also has something which is, well, different, let's say, than the other graph flavors around, especially when it comes to the query language. So Apache Tinkerpop has its own query language, which is called Gremlin. And what's special about Gremlin is that, as opposed to pretty much all other graph languages I'm aware of, I think, it's a procedural query language as opposed to being declarative. What that means in layman's terms is that, well, if you write a query in any other query language, be it Sparkle or Cypher or whatever, you don't have to actually specify how you want your operation to be done. You just specify what it is you want done. In Gremlin, it's a bit different. You actually have to specify step by step how you want your query to run. And for some people, that's, well, some people love it because they like that fine-grained control. And that way, we should also mention that it's possible to have to exercise control over how your query is going to run. And if you are very familiar with your data and the way it's distributed and things such as frequency indicators and all of those things, you do have a fine-grained control over how your query runs, and therefore you can make it run in a more efficient way. The flip side of that is obviously that, well, it's more complex to write a query in Gremlin as it is to express the same query in other query languages. So having said all that, I'm wondering what's your take on different graph query languages and their support, and if adding an additional query languages on top of Gremlin is something you may consider in the not so distant future.
Yeah, so I think that, this ties back to a theme in our discussion here, which is, we tend to, solve data management problems for the most complex and the most highly scaled, demanding solutions, right? And so, as you mentioned, having that control, being able to optimize it, spending that extra time maybe in developing that application matters in those situations, because it has to run efficiently and, with high performance. That's the type of customers we service. That said, um, we've been trying to make, use of computers easier and easier and easier all the time to make everybody be a programmer. Maybe generative AI solves all of this, right?
Hmm.
But I think with respect to what we're talking about here, we also are looking at supporting the coming standards. There's now finally sort of a standards effort around graph languages, and they derive from Cypher, and that language that you mentioned. And there is the OpenCypher project on top of Tinkerpop. And one of the things we found when we started looking at it, and we recently decided to do OLAP primarily from customer demand, but it turns out that us providing the analytical capability would be easier than doing the work to support Cypher, OpenCypher, and replace Gremlin, or to have a pluggable model like that. And we decided that that effort is going to be substantial, but we also decided that we'll wait for the standard to solidify. And instead of implementing Cypher, we'll implement that standard, which is going to derive from that OpenCypher work, I think, right? That's going on in the Apache community.
Yeah, it is going on indeed. And yeah, like you said, it's work that we expect to actually solidify sometime soon. So I can see the point in waiting for that to come out rather than well, sort of not exactly rushing
Twice.
out.
Twice. We
Yeah,
always have to think about, the cost in the game as well, right?
indeed. So I guess based on what you said, I can already infer the next things that you're working on. You already mentioned adding analytical capability, so all up, and that's probably more immediate than the mid to long-term goal of adding another layer of graph query language. Is there anything else that's in your roadmap for the coming period?
I think that the other piece that I did mention was that we will be putting this up on our database as a service
Right. Yeah.
solution. And that, what I will say is everybody wants to move to the cloud. It's non-trivial to get that right. And so we've already started initial work on that. There are a lot of learnings from us as we made, multiple starts at putting up a database as a service just around Aerospike and, its use as a database. And doing this on top of, with the Gremlin and Tinkerpop scaling in one manner and the database scaling in another, and really making that be opaque to the end user who just wants to spin up a cluster of Aerospike Graph, is something we've already started work on, and you'll see that come out, as I said, sometime next year, hopefully before the end of the first half of the year.
Yeah. Yeah, I do realize, as you also pointed out, that it may seem trivial if you're only interested in using the end product, the service, but it's actually not at all if you're the one who has to implement it. So I understand it's going to take you a while.
Exactly.
Okay, great. Thanks. I think we're about at the top of the hour, so it's probably about time we wrap up as well. So I don't know if there's anything else that we didn't touch upon and you feel like we should, but if not, I would like to thank you for joining today and for sharing what you have with me and the audience.
Well, thank you, George, for having us, for having Aerospike participate in your podcast. And, always love to talk to you and have learned a lot and from interactions with you. And, thanks for your support for the graph community in general, right? I think that it's still one of those technologies that needs evangelists broadly, and you're one of the leaders there. So thanks for that.
Thanks for sticking around. For more stories like this, check the link in bio and follow Link Data Orchestration.